SAS Model Studio includes a suite of integrated tools to facilitate end-to-end data mining analysis. In this demonstration, you'll see multiple methods for building, evaluating, and comparing models. If you have access to SAS Viya, I encourage you to follow along with me. Your environment may already have all the files used in this demo. However, if you don't see them, please visit our SAS software GitHub page. The SAS Viya Quick Start repository provides the files used in our demonstrations and instructions to load them into your environment. A quick note before getting started, a few of the steps in this demonstration take several minutes to run, so some of those waiting periods will be sped up. To open SAS Model Studio, go to the Applications menu and select Build Models. The Projects page appears with a tile view of any projects that have already been created. To start fresh, click New Project and give it a name, Home Equity Analysis. For the first scenario, we'll begin with a blank template and use SAS Viya Copilot to guide the model building and evaluation process. Next to the data field, click Browse. Choose the Home Equity data source and click OK. Before saving, let's take a quick look at some advanced options. Click Advanced, then select Partition Data. Notice that by default, the data is divided into training, validation, and test partitions, exactly what's needed here. Click Save, then Save again to create the project. The project opens on the Data tab, and now it's time to set up the modeling properties for the variables. Take a closer look at the variable named bad. Model Studio has detected that it's a binary variable and assigned a role of input. But bad actually represents the outcome of each loan. Select the row for bad, and over in the Properties panel, change the role to Target. Variables can also be flagged for bias assessment, which is really useful for responsible modeling. Select Job, check the Assess this variable for bias box, and then change its role to Rejected so it isn't used as a predictor. Next, switch over to the Pipelines tab. The template only includes the data node at this point. To bring up Copilot, click Show SAS Viya Copilot side pane. Right away, Copilot suggests running this node. Click that prompt button to run the data node. Next, type Suggest Next Node and press Enter. Copilot offers a couple of options here, adding specific nodes or kicking off a longer process that trains and compares multiple models. Click Start Exploration. This will run for about 2 minutes, trying several different models and providing updates in the chat window along the way. While Copilot is working, let's set up an alternative approach. Click Add New Pipeline. And this time, we'll generate models from a predefined template. Make sure Select a Pipeline Template is selected, click Browse next to the Template field, and choose Advanced Template with Class Target. Then click OK and save. Let's look at this Pipeline 2 tab. After some pre-processing, the data is trained and validated on 6 different models. It also creates an ensemble of those 6 models, and then all 7 are compared at the end. There's full flexibility here. Settings on any node can be changed and new nodes can be added. For now, just click Run Pipeline. While that's running, let's add one more pipeline. Click Add New Pipeline again, and this time let SAS handle the entire training and selection process automatically. Select Automatically Generate the Pipeline, set a time limit for 20 minutes, and click Save. Just a heads up, this automated process does take a while to run, so feel free to skip this step if you're following along. Let's jump back to the Pipeline 1 tab and check on Copilot. The exploratory process is finished, and Copilot is recommending the top 3 models. The gradient boosting model came back with the highest KS statistic, so select the first recommended option to add it to the pipeline. Copilot provides a nice summary of the actions it took. Before running this model, we can ask Copilot to add another option for comparison. Select the data node, Then ask Copilot to add a logistic regression node and run it. The basic logistic regression node is added, but the model could probably use some tuning. Type Improve the model and press Enter. This kicks off an improvement process that tries different combinations of settings and hyperparameters to boost performance. It runs for about 2 minutes and can be stopped at any point. When it finishes, Copilot summarizes the overall improvement and shows exactly what settings produced it. Click Apply Improvements to Node. So now this pipeline has 2 models available, gradient boosting and logistic regression. One of the great things about Copilot is that it can also explain concepts and point to references. Try asking, what is the difference between logistic regression and gradient boosting? And there it goes. Copilot returns a description of each model type, their strengths, and ideal use cases. Even better, it includes links to SAS documentation for digging in further. SAS Viya Copilot and pipeline templates provide a really nice guided experience, but you can also take full control by building custom models, including open source ones. Click Nodes in the left panel, expand Miscellaneous, and drag the Open Source Code node on top of the Data node. In the Open Source Code options, click Open Code Editor. We've provided model scoring code on the SAS Software GitHub site. Open a new browser tab, and click the GitHub bookmark, which goes to github.sas.com/sassoftware/SAS Viya Quick Start. Click train_homeequity.txt, copy that code, and then paste it into the training code window back in Model Studio. Then head back to GitHub and open score_homeequity.txt from the repository. Copy that code, return to Model Studio, and paste it into the scoring code window. Then click Save and Close. Once the training and scoring code are in place, any of the settings in the open source code pane can be adjusted. In some cases, SAS formats need to be disabled when processing data with Python, so expand Data Sample and clear the Include SAS Formats checkbox. The last step is to right-click the open source code node and select Move and Supervised Learning. That connects it to the Model Comparison node. Now, click Run Pipeline to update all the nodes in the flow. The Python code runs alongside the SAS models and is included in the comparison. If the automatically generated pipeline was set up earlier, this is a good time to switch over and check on it. Once it's finished generating, click Run Pipeline there too. When everything finishes running, green check marks appear on each node, the signal that everything ran successfully. Let's return to the Pipeline 1 tab. Then right-click the Model Comparison node and select Results. A champion model has been selected within this pipeline based on the KS statistic. Clicking Assessment brings up plots showing model performance, plus a fit statistics table where all the different models can be compared head-to-head. Click Close to exit. Results for any specific model are also available. Right-click the Gradient Boosting node and select Results. This view shows variable importance statistics, error plots, and several useful types of code. Clicking Fairness and Bias allows variables to be checked for potential bias issues. Then close out of this view. Now click the Pipeline Comparison tab. This is where the winning models from each pipeline are compared against one another, using the KS statistic by default. That selection statistic can be changed if something else is preferred. An overall champion model is crowned from the group. The Insights tab is definitely a highlight. It generates a natural language summary that interprets the pipeline comparison results, along with a great set of assessment graphs. To share these results, click Export to PDF. Customize the contents of the report, and then click Export to download it through the browser. The final step is registering the champion model for later deployment. In the Pipeline Comparison tab, right-click the champion model and select Register Models. Then click OK to register it in the default location. Once the registration completes, click Close. The model is now available in SAS Model Manager, where the next step in the data and AI lifecycle takes place, deploying and managing production models. That's a quick tour of SAS Model Studio. To learn more, click Help to visit your SAS Learning Center and explore the documentation.